use in data science. Actually today it's going to be a very new topic. It's called learn PID using machine learning. So as you can see on the screen, is it possible to do the PID, proportional integral derivative controllers, using machine learning? This is the part 1 of the video. So as you know, the PID theory is that the program is based on the principles of PID control, a widely used control strategy in control engineering. And the basic principle of PID can be explained here. Suppose you want to control the heat of a particular location at, let's say, some 35 degrees. This is a set point. If you just put on a heater, it will not go and stay at 35. It will go above and it will go and saturate maybe somewhere around 55, let's say in this particular case. So that is where the PID, the closed loop controls, come in, where you can stop at exactly the set point. Let's say 40 is the set point as you can see on the screen, and this is the feedback temperature. This is the error between the set point and the process variable here, the temperature which is coming in. This is the error, and a PID algorithm can make it stabilize exactly at 40. So how you can do that? You can use a software called temperature control lab actually that can simulate a PID and further create a machine learning algorithm. So in PID, error ET is nothing but the error of the PID controller that calculates an output based on the error between desired set point and the current process variable. Now Kp and Ki and Kd, those who are familiar with PIDs, it is nothing but some proportional constants and integral constant and differential constant. So the entire theory looks like this. This is the most important diagram. So set point is RT, you are giving 40 degree, let's say. This is the temperature which is coming in. The difference between these two are taken as the ET, and this is also, the temperature is also called a process variable sometimes, not sometimes, always. And this is the ET, and this ET error is going into 3 different parts, that is P, I and D. P is calculated by Kp, the proportional constant, into error multiplied by error, and I is calculated Ki multiplied by addition or integration of all the errors. D is nothing but the difference. Kd is a constant and difference in the errors. So difference between the successive points, that is what it is. And you add all of them together and finally produce a YT, that is a power which is going to the heater, and heater heats up with the temperature sensor which gives the temperature back. So the equation can be written like below. So where the P is proportional to the current value of SP minus PV error. PV is here, SP is here. So this is the P. P is actually, this is what they are saying, the term P is proportional to the current value of the SP minus PV error. Now I accounts for past values of SP minus PV error and integrates over time. So exactly here, this is SP minus PV integrated. The D is the best estimate the future trend of the SP minus PV error. So everything is input is error, that is like SP minus PV. SP is RT, PV is something which is coming from here which is not marked. So finally the output will look like that. You can see that actually as you vary Kp, Ki and Kd, it will go and stabilize at the set point. Let's say instead of 1 here, it may be 40 degree centigrade. And PID using machine learning, how is it possible? That is what we have to do now. The PID simulation program is responsible for creating such a setup. Thanks to the the control engineers' contribution to make a temperature control lab program, and in the description I will thank the team for that. Now the data set has to be created of many set points. That is what you have to do. So you need not create hundreds or thousands of set points. You can create some number of set points. After that, any neural network can map it or non-linearly, make it work actually. So, because neural networks can map non-linear functions. So, you have to create a large number of data sets. How do you do that? Data set of many PID parameters you have to create. So, this is a simulation program we will be using instead of a hi-fi big setup, and later this will work with a real setup also. So, the program flow is going to be like this. There is a factor called a speed up 100. That means in normal scenario, suppose you want to run this experiment for, let's say, 5400 seconds. So you can simply give speed up is equal to 100. So, or let's say 70. 70 means it's a 14 millisecond. That means 1 divided by 70, that is 14 millisecond. If it is 100, 1 divided by 100, that is 10 millisecond. Every loop will run. And Kc is equal to 6, that is the PID parameters. And there is something called a tau I, that is 75. Then there is a tau D, which is 0. Okay, these are the parameters which are to be fed into the system. Now, this is now more a PI controller than a PID because D is 0. Now, the way you call the simulation program TC-lab is equal to tclab.setup. When the device is connected, there is a hardware which is going to be connected by the TC-lab people, but you don't use that. I will create my own very small, cheaper device for you. That will be in the next video. And so you are not going to use this line at all right now. You will use this line, except it will be, the faults will be kept as well. You are not going to use their own hardware. We will use our own hardware, so you can keep it false, and speed up factor is anyway taken by the TC lab. The next is actually define the PID control parameters. Like, there is a function called PID. That is what is going to create a PID function. PID function is nothing but, as I said, this is a integral of the error, difference of the error, and also a proportional of the error. So Kp and Ki, Kd have to be calculated like this. Kp is equal to Kc. Ki will be Kc divided by tau I. This is there is a theory behind all this. The PID theory, if you read this, can be approximated like this. And Kd can be this one. Now, this is a U bias. That means when the system is put on, some power may go into the system initially, maybe 0.3 or whatever, actually 30%. So that you can set here. In this case, it is 0. And upper and lower bounds, actually, whether the valve or output valve or whatever your heater, it has to go power from 0 to 100%, or in between, you can set that. So now the function continues. The error is calculated as SP minus PV. I error is nothing but I error plus Ki into error into dt. Dt is the successive time slice, the timestamp you can say. And you can see that this you can skip, this is not that important. Now here P is equal to Kp into error, that is how you calculate, and I is equal to I error, D is equal to whatever way PID parameters are calculated. Now OP is nothing but addition of all three. And how this addition of all three comes? If you look at the earlier diagram, see that all three are added here. That is the UT part actually. That is what here it is getting added. OP0 plus P plus I plus D, that is the output. That this is a function, it returns output, that is the power, and PID values. The program flow will be generate random set point profile with varying set points over time. Then save the collected data into a CSV file, that is nothing but your data set for further analysis. Simulate the TC lab system with the PID controller, that is the next thing. So collecting data on heater values, temperatures and time, etc. is done using the TC lab, and you can see the principle is going to be the PID controller aims to minimize the difference between set point and temperature, and the proportional term responds to the current error, integral term, accumulated error, derivative term, the future error. The complete program is going to be like this, and these are libraries of Python which you have already seen, NumPy, Pandas, and plotting library, matplotlib, etc. etc. TCLab is the more new one which can be freely downloaded for interacting with hardware, allowing to control heaters, temperatures, read temperatures, and synchronize actions, etc. These are standard libraries, NumPy, etc. and TCLab is extra. The first thing, as I explained earlier, speed of CPU is equal to 100. You are calling a TCLab function. So this already we have explained. Then the PID function, which I already explained to you. You can stop the video and see one more time. So all the explanations are given here. Now the Kp is nothing but Kc, and Ki is equal to Kc divided by tau I, and Kd is equal to Kc multiplied by tau d. This is kind of multiplication things you have to do. Create a new kind of Kp, Ki, and Kd. Now you have to generate. Now what you have to do is you have to generate many set points, not thousands of them, few of them. So the set point, actually the width, you know how much time one set point should stay. That is what actually is we are going to decide here. So for example, now our experiment is, let's say runtime is 90. 90 means 90 minutes. That means 50 each second. How many seconds? 5400 seconds. That means 5,400 rows of data you are going to generate. Now this you are going to create a constant called loops. That is nothing but 60 multiplied by runtime. That is 5400. Now you are simply initializing with zeros T1, Q1. That T1 is the temperature, and Q1 is the power, and Tm is in seconds. Now you are going to call this, and you are going to say that TSP1 also is going to be the zeros. This is actually the zeros of the loops, actually number of loops, actually that is what we have calculated earlier, multiplied by T1. Now what you are going to do is actually you are going to create variable set points from 30 to 70 only. Okay. Now so what you do is actually here you have to always say first initially 30, because first 30 seconds of temperature point is fixed at one particular value. Now what you are going to do is you are going to run a loop actually, which is going to be running 5,400 times. It will generate T1, Q1 and time in seconds, and P value, I error value, D. 1, 2, 3, 4, 5, 6 rows will be calculated, put into an Excel file. So this is the program which does that actually. That means you see that now the x-axis will vary from, set point will vary from 240 to 600. That means minimum 4 minutes at least one set point will stay, maximum 10 minutes. It will be randomly selected. So each set point will stay between 4 to 10 seconds. And the set point value, how much time it is going to stay, but value will be randomly selected between 30 and 70. Few set points will be randomly selected. Now these are just plotting functions, etc., etc. Now you can see this is what it will create at the end of the program. Initially, as I said, 30 is kept. From there it will be generated random set points. You never know which one will be generated. And if the width of it, again I said 240 to 600 seconds is program itself decides randomly. So whatever you get, you should be happy with. And some kind of profile will be created like this: random set points and random widths of the duration of the set point. So the explanation of this is given here. You can stop the video and see later. And now at the end actually you are going to print out actually whatever values you could see in the graph actually that was printed out in the program. This is basically to print out each and every line which is being written to the Excel database. So you can see that this is how the format of the data which you are be generating, that is 5400 lines of data it will be generating. The time, set point, T1, Q1, PID, and there is something called an absolute error. You can see in the diagram SP is here, T1 is here, Q1 is here, all those things are there. PIDs are here, like you can see here. Now you can see the CSV file will contain all these values. And now save the selected data into a CSV file, that is nothing but your data set. And now once you have this data set ready, the data set can be fed, can be used as a basic data set of a PID. So that was the most important part. You can see the Q1, T1, TSP, error, etc. practically how it was looking like, and this is what you have created. So it has simulated the profile of the PI system trying to reach the set point. So the entire graph what you see has been divided into 5,400 rows, and data has been stored. This picture is converted into numbers, that's called the data set. And you will look for the next videos for the continuation of this. Thank you.